Hello everyone. So now I've got a Marshall JTM45 reissue from the 90s on the bench. This thing has had a previous tech work on it before and there's a lot of issues, so let's get started on it. So the first thing that I kind of checked was the filter cap on the side. I noticed that the bolt had backed out and the cap was easily able to be removed just with a little bit of pressure. On the back side of the amp, you can see I've went ahead and swapped the power tubes. Now, the Marshall JTM45 uses 5881 power tubes, but this had a set of EL34 Wing C power tubes in it. As you can see, one of them has two black spots on it. That's because the output transformer is meant to have the 5881 power tubes in it, but the EL34s are looking for a bit different output transformer. Looking on the inside of the amplifier, you can see first the cap that's on the presence control is mounted way off of it, just kind of dangling out into space. Looking a bit closer at the board, you can see just solder blobs on the two wires coming off of the board, and the bias potentiometer has a whole bunch of corrosion on it. So that needs to be replaced as well. A little bit further down the board, we can see this twisted pair of red wires running down the filter capacitor that are just way too long for this run needed. But those wires could be trimmed a lot closer to the filter capacitor because there's about half of an inch of bare wire sticking out that is really close to the chassis. Now a little further down we can see the V1 cathode bypass capacitors. They used 2 instead of the proper value. It's just installed in not a good way where they can rattle loose and the connections are not very good. Also not the right value. Looking at the potentiometers, these are potentiometers meant for a circuit board, not the eyelet style you would normally associate with this type of wiring. Also, the bright cap on the treble channel wasn't even fully connected and had come loose. Another thing about this board is that it was completely loose. It wasn't even completely tight all the way, so loose hardware in this amplifier is kind of a common theme here. So let's go ahead and start getting this amplifier torn apart so we can take a look underneath the board. So looking underneath the board, we can see a lot of burnt wires where someone was a little careless with a soldering iron. We can also see off to the side the little red wire that was cut that was originally running down to that filter capacitor instead of doing it the proper way. So now I've got some work ahead of me getting all this cleaned up. So stay tuned for more. Please like and subscribe. Getting into this thing, one thing I didn't realize when I was kind of tearing everything down is that the presence control was completely wired wrong. And I don't mean wrong because it's not the way I wire it. I mean just plain wrong. It was wired kind of like the newer Marshalls was, but missed the resistor and was the wrong value pot. So I put everything back to the way it's supposed to be in this amplifier, which can be a little bit noisy when you move the pot because there's DC voltage on it. But that's how this is supposed to be wired for this amplifier. As you can also see, I'm taking a note from Lyle from Fisonic and upgrading the grounding scheme in this amplifier to one to reduce the noise. Thank you, Lyle, for that tidbit in the videos. So looking at the board, unfortunately, because of the previous tech who worked on this, really butchered this thing. I wanted to lower the capacitors that you see kind of floating in the air down on the board so they're more stable. However, there's so much damage on the board that I didn't feel comfortable doing that. So I put a little bit of silicone on the capacitors to kind of stabilize them in place. The client and I are also discussing about doing a gut and rebuild on this amplifier, replacing the board and some of the transformers due to some issues that the previous tech caused. Now, it's important to use silicone and not hot glue Some people may think this is hot glue. It's not, it's silicone. These things get hot, and when hot glue gets hot, it's no longer glue. So it's important to use silicone in these amplifiers. I've gotten all the generic SM capacitors out and replaced with high quality ceramic disc. It does affect the tone and the longevity of this amplifier. I've also replaced the bypass capacitor on the first stage, which was the wrong value to begin with, and it was just horribly installed with two capacitors doing the job of one, let alone that capacitor. My cost is 75 cents versus about the $1.25 they spent, so it was less expensive anyways. I know everyone wants to hear Marshall's cranked all the way up, so I've got some playing clips with different speakers and different EQs. I'm going to put the EQs up on the screen while you guys are hearing it, and I want y'all to play a little game to figure out what speakers I'm using. I'll give you a hint. One of them's a Vintage 30, the other one's an EV, another one I'll throw in as a mystery. So take a listen, see what you guys think, like, comment, subscribe. Thank y'all. Hey y'all, so I wanted to go over determining which way you need to install these coupling capacitors. Now sometimes you'll see on the capacitors there'll be like a band on here, but these tad mustards are not marked, and even those with the band on there, I still highly recommend you check because they can be marked incorrectly. So I'm doing this with a scope, but you can also do this with just a guitar amplifier and a cord. So with the scope, what I'll do is I'll connect the probe, positive one leg, ground on the other, and hold. Let me adjust this down a little bit so you can see. So you can see about how big the waveform is there. So now let's swap it around. And you can see how much smaller it is now. How much smaller the waveform is. So that means that the side that the ground was on, so I've already marked it here, this is the side that needs to go towards the ground direction. Basically, you want your signal to flow through basically this way. So signal in, signal out is kind of how I like to think about it. So let's get these put on the turret board and go from there. Alright, so before I install the resistors, I kind of want to go over the different types of resistors that I use. First ones are these brown bodied ones that a lot of people have seen in vintage amplifiers. These are carbon comps. Most of the time I will use these in the signal path. So like the grid stopper resistors, slope resistors, any sort like that. These yellow bodied one are carbon film. They are more stable than the carbon comps. Sometimes I'll use these in the signal path, but in this case I'm going to use these as plate resistors. They've got a little bit more of the vintage tone to them. Then these are these blue bodied ones. These are metal oxide resistors. They can handle a good bit of power. That's the reason why you typically will see these in the power supply as they're dropping resistors. Sometimes you'll see these used as plate resistors or cathode resistors. I generally don't. If I'm not using carbon for the plate resistors, I would be using these metal film resistors. These are the ones that are going to be the artificial center tap for the filaments on this amplifier. These are Dale R65Ns, I believe is what the number on them are, or 60s. And these are mil-spec resistors. Dumble used these as the plate resistors in pretty much all of his overdrive specials. Last are these sandcast resistors. They're wired wound. One thing you have to watch out for with wire wound resistors is kind of stray inductance. Never really want to use these in the signal part of the amplifier, but they can be a great addition to power supply to help knock down a little bit of noise. Because your choke is essentially one big inductor, and these kind of act like a small inductor. Something else I want to show is on this one right here, because the body of this capacitor is exposed and it's also the negative, I've got some, not heat shrink, but this is just stripped off of a piece of wire and going to use that to add some insulation to this. So now we've got this insulated, and it's also, it's hard to tell, but elevated above the capacitor. One thing you may notice is traditionally in this spot, you would see a 820 ohm resistor. I'm using a 1K. So one of the things I do to simulate a vintage amp is generally increase the value like one standard up. So for example, these resistors here that are going to be the plate resistors, you can see on the package they're 110K. so it simulates like a drifted resistor. So that's about all I have for today. So I will get back on this later and got to order a new capacitor because that one broke. Just my luck. Thank y'all. Have a great day. That's why I don't play guitar anymore. So finally finished with this hand wire conversion on this JTM45. So I just want to kind of go over some of the pictures that I took. This is before I zipped everything up to keep the wires together that need to be together and those that need to be separated. So in this picture, you can see the additional filter cap that I installed inside the amplifier. One thing to note here is the one that's on the side is the main one, and it's wired so that the tube rectifier goes directly to the HT fuse. The HT fuse goes to the cap, and then the cap goes to the standby switch. Originally, the way Marshall had this wired was the tube rectifier went to the fuse, then to the switch, then to the main filter cap. The issue with that is capacitors that are completely drained are essentially a dead short until they get a little bit of charge in them. So there's a huge inrush of current when you flip on the standby switch for the first time. And frankly, this amplifier doesn't need it because a 5AR4 rectifier tube has what's called a soft start. It takes it a little bit of time to develop the voltage, which gives everything time to warm up. So got that. You can kind of see in the background the artificial center tap I did with the 2 Dell resistors. And I did finally get the replacement capacitor for the bias section. Then a little further down the board, you can see the Larmar master volume that I installed. It works really well in this amplifier. Believe it or not, this is the first one I've done with one of those. I've read about it, heard it, and it worked amazingly well in this amplifier. It's a little bit messy here, but I got everything cleaned up before everything was buttoned up. No shielded wire needed. The twisted pair worked very well because of common mode cancellation. Because the signals are out of phase with each other, they don't cancel the guitar signal. But if there's hum, that would be in phase and that would be canceled. And then the bias wire wraps around it for a little bit of extra shielding. Then down in the preamp section, you can see the carbon comp resistors that's in the signal path. I do that on a lot of amplifiers. I want to have a more vintage sound. You could use carbon film everywhere if you want to, but it's just a nice little added touch that I use, and you can see the ceramic disc capacitors in there as well. Pretty nice how it turned out. So, what you all really want to know is how does this compare to the other version? And also, what speakers did I use in the other version? Was it all truly 3 different speakers, or did I pull a fast one? Let's compare those.